Chapter 3, Section 4. In this section, we're going to learn how to graph the functions listed in the library of functions and how to graph piecewise-defined functions. So now let's look at the first, graph the functions listed in the libraries of functions. The first function listed in the library is called a square root function. Okay, square root function, the standard form is f of x equals square root of x. Okay, the name of the function is called a square root function. So in the previous sections, we learned the property of function, right? So let's quickly review what we have learned. We have learned the intercepts, right? How to find the intercepts of the function, and then even or odd function, right? Even or odd function in the graph point of view is also, indicate, the graph is symmetric with respect, it's we call the symmetry property, right? And then what else we learned? We learned function is whether increasing or decreasing, right? That's one of the property of the function. And then what else? The local minimum or local maximum, right? Local. And then absolute minimum or absolute maximum, right? So those are all the properties of function, okay? And then let's see square root function. Remember the domain of the function when we have a square root, right? Even index of the roots, and then the requirements is the radicands must be greater than or equal 0, right? So that's the domain, or also the function, domain and the range. Don't forget that, domain and the range. All right, so first we can find the domain, right? Domain is x must be non-negative number. What about the range? Range is the same, right? Non-negative real number. So domain and range are sets of non-negative real numbers. And then what about intercepts? We can find intercepts. Let x be 0 and then evaluate y, right? So if let x equals 0, and then square root of x is also 0, right? Square root of 0 is also 0. And then let y be 0, so square root of x equals 0, and then we can also solve x equals 0. So that means both x and y intercept is at the origin 0, 0. All right. And then we can, make a data table. Okay, so we can plot some of the points, x and then f of x, right? Which is square root of x. So pick up some of the points, like a 0, square root of 0 is 0. If x equals 1, square root of 1 is 1, right? If x equals 4, square root of 4 equals 2. And then if x equals 9, square root of 9 equals 3. If x equals 16, square root of 16, that's 4, and so on. Okay, and then we can plot those points. Okay, and then use the smooth curve, and then we can graph this function. And then from the graph, we can see this graph doesn't have symmetry property, right? Not symmetric with respect to the x, not symmetric with respect to the y, right? Not symmetric with respect to the origin. So no any symmetry property. So since no symmetric with respect to y, no symmetric with respect to the origin, that's why the function must be neither even nor odd, right? Remember the theory, that's the if and only if case, right? That means both direction. So if the graph symmetric with respect to the y-axis, then function is even. If symmetric with respect to the origin, then function is odd. So since not symmetric with those, that means function neither even nor odd. And then from the graph, we can see from 0 to positive infinity function is all the way increase. Okay, no decreasing part. So since no decreasing part, no turning point, therefore no local minimum, no local maximum. Okay, so graph increasing on the interval from 0 to positive infinity, and then no local maximum, no local minimum, but it does have an absolute minimum, which right at the origin 0. Okay, the minimum value is 0, and then it occurs when x equal to 0. So that refers to point 0, 0. And then you need to remember the shape of the square root function. Okay, it's like this way. So how you can remember the shape of the square root function is something like that. So actually you can, think about quadratic function. Remember, quadratic function is parabola, right? U-shaped. So square root function actually is a parabola, rotate 90 degrees to the right hand side. Okay, rotate like that, but only half of it, only this part. Okay, so this is half of the parabola, but in the rotate to the right hand side 90 degrees. Okay, so if you think about, okay, this is a parabola, and then you rotate 90 degrees this way. Okay, and then this part actually become this part. Okay, that is the square root function. All right, I hope that helps you, okay, to memorize what the square root function's graph look like. Okay, parabola, the whole thing rotate 90 degrees, and then the first quadrant, this part of the parabola, half of the parabola, but rotate 90 degrees, that's the square root function's graph. All right. So the next one, let's look at a cube root function. So what is the standard form of cube root function? Is f of x equals third roots of x. Okay, this 3, that's the index of the roots. Index of the root. Okay, so in this case, it's the odd number. Okay, so since it's the odd index of the roots, so that's why it doesn't have any restriction. So domain will be all real numbers, right? And the range is also all real numbers. Okay, so domain, it should be from negative infinity to positive infinity, and then the range is also from negative infinity to positive infinity. So we want to study this function, and then if we can answer the following 3 questions, that will help us to get a graph of this function. Okay. So first, determine the function is even, odd, or neither. So remember how to determine function is even or odd or neither. We need to evaluate f of negative x, right? So that's third roots of negative x, right? That's simplify as you can consider negative x as negative 1, right? You can consider like this, negative 1 times x, which is the same as third roots of negative 1 times third roots of x. So third roots of negative 1 still negative 1, and then third roots of x still third root of x. So that's simplified as negative third roots of x. Okay, third root of x, this is f of x, right? So that's negative of f of x. So f of negative x equals negative of f of x. That's satisfying the definition of odd function, right? So f of negative x equals negative of f of x. So that's why function is odd. Since function is odd, and then graph must be symmetric with respect to the origin, right? So function symmetric with respect to origin 0, 0. Okay, so we done the A part. B, determine the intercepts if there's any of the graph of f of x equal the third roots of x. All right, intercept, so let x equal 0, okay, plug in. So f of 0 equals what? third root of 0. Third root of 0 is still 0. Okay, so x-intercept is 0, 0. What about y-intercept? Let the y-coordinates be 0. Right? So we have 0 equals third roots of x. And then both sides of the equation raised to the third power. And then we can solve x still equal to 0. So that means both x and y intercept is right at the origin 0, 0. All right. And then the third part, graph. In order to graph this function, and then we need to, find a data table, right? Same thing as we did before, x and f of x, which is y. So we can do maybe 91, right? 91, third root of 91, still 91. Is that right? Third root of 91 is a 91, 0, and then 0, 1. 1 is also 1. And then we can do 8, right? X equals 8, and the third root of 8 is 2. And then we can, based on those points, graph. All right, so we can use this one to do the graph like that. So actually very similar as square root functions graph. Okay, so we got this half, and then based on the symmetry property, we know graph must be symmetric with respect to the origin. That's how we can get the other half. Okay, so if you already know symmetry property about function, you only need to get a half of the graph, and then based on symmetric property, you can get the other half. All right. So that's how we get a graph. Any other? I think that's it, right? That's A, B, C we done. So square root function is just like you only see the first quadrant, okay? The shape is pretty much similar as square root function. This is the third root function, so we have the other half. That's how we distinguish, okay, square root function and a third root function. Square root function only have the first quadrant part. Okay, third root function, we have both first quadrant and the third quadrant, like that. Okay, this is f of x equals square root of x. This graph is f of x equals third root of x. And then based on what we already talked about, and then we can put all the property of third root function in summarize here, okay, all the properties. Domain and range are real numbers, okay, we talked about that earlier, right? Both x, y intercept at origin 0, 0, okay. Function is odd function, right? We already tested, so graph symmetric with respect to the origin. And then graph, what about increasing, decreasing, all the way increase, right? From negative infinity to positive infinity, all the way increase, no any turning points. So that's why no local maximum, no local minimum. Okay, increasing on the interval from negative infinity to positive infinity. The function does not have any local minimum, local maximum, and since is not a closed interval, so there's no absolute minimum, no absolute maximum either. Okay, it just doesn't exist. It only exists in the closed interval. Remember extreme value theory, right? Since it doesn't have turning point, that's why no local minimum, no local maximum. Okay, this is the third root function.